Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is the Oracle Cloud Operations Quick Start, which will cover the fundamentals in operating in OCI, best practices, as well as key services available for maintaining your tenancy. I'd like to introduce Olivia Ferda and Uma Kumar as today's presenters. That said, I'll hand it over to Uma.
Thank you, Borna, and welcome everyone to your Day One and Beyond session on Oracle Cloud Operations. So like Borna mentioned, myself and my colleague Olivia are going to be taking us through today's session. So let's go ahead and get started. Brief agenda for today's session. What we will be covering today is first we're going to talk about what we mean by operations on OCI. The word operations can kind of encapsulate a lot of different things, from security to monitoring and management, infrastructure as code. So we'll kind of discuss all the different types of tools you'll be using and maybe different tasks somebody would be delegating when they're dealing with cloud operations. Then we'll discuss the different ways to access OCI, so through our normal GUI console, and the several different ways a developer or operations person would be accessing OCI. Then we'll start our introduction into infrastructure as code and how you can get started in provisioning your infrastructure through different tools like Resource Manager and Ansible. And then in the second half of the session, Olivia is going to walk us through the observability and management platforms. This is a suite of different platform tools and management services that will all help with everything telemetry based within OCI. And the movement of your data, monitoring your different infrastructure, being able to notify your teams, so on and so forth. So she'll be taking us through monitoring, notifications, events, functions, and logging. So some objectives that we have by the end of this presentation, we want you to be able to explain, understand the core areas and principles of how we're defining operations in OCI, be able to describe the different tools available to deploy and manage your resources, define potential use cases for these operational tools, especially with observability and management, and then understand Resource Manager and how to create a stack to help you provision your infrastructure. So we'll have a couple of demos as well sprinkled in today on the different topics that we're discussing. All right, so let's go ahead and get started into what is cloud operations. So like I mentioned before, cloud operations could mean a variety of different things. For the sake of simplicity in today's sessions, we have simplified it down to 6 different verbs that you see on the screen. And underneath each verb, you'll see some of the different tooling that can kind of help you achieve each step. So starting on the left-hand side, we have build and configuring your environment. This is if you're, net new to a cloud and you need to build out your infrastructure to run your different workloads and applications on. There's different ways to do this, right? You can take the manual option, but when we think about operating in cloud, we really want to emphasize on the automation aspects of it. So you want to be able to take advantage of different automation tools for your day-to-day operations, including the provisioning of your infrastructure and resources. So we'll go into infrastructure as code in a moment, but just some tools that we'll be discussing today will be things like Terraform, Resource Manager, and Ansible. After you've gone in and you've configured your environment, you need to understand with your daily deployments, being able to monitor your workloads, monitor your infrastructure, be able to take action, so notify different teams, maybe understand the different events that are happening, connect them to functions to automate like responses to things. That's going to be under monitor and protect. And that's where we'll be taking a look at some of the observability and management tools like functions, events, monitoring, and notification. We also have secure and governance. This is, not like a final step. It's kind of throughout this whole process, something that you should be aware of. But understanding things like your audit logs and the different logging tools to help you kind of troubleshoot things, understand if there's any sort of security risks or threats that have happened, be able to kind of trace back and see which users took what sort of action or API calls that were made. That's going to be very important. So we'll discuss audit logs and logging and how you can use that to better secure your environment, as well as governance. This is probably going to be the first thing that you do before you even go into building and configuring. You need to make sure that your users have the proper access to OCI. So OCI is denied by default when you first go in as a user. You won't be able to see or create anything. How you are granted those permissions are through identity and access management policies. So we won't be spending too much in IAM today. That's a whole separate session, but still very important to operations and just working in cloud in general. All right, so now let's talk a little bit about some of the different ways to access OCI. So I'm going to give you a brief overview of all the different methods you see on the slide here, and then we'll actually kind of double click into all of them in upcoming slides too. So the first one that I'll call out is hopefully the most familiar to everyone here. It's the OCI console. So this is an intuitive graphical interface. It lets you create and manage instances, cloud network, storage volumes, as well as users and permissions. You can access it through cloud.oracle.com. And again, to be able to work with any of the resources in the console, you once again will need the proper identity and access management policies in place. The next option are your typical REST APIs that use HTTPS requests and responses. Those are Oracle Cloud Infrastructure APIs. Developers use them, in conjunction with our software development kits to build out applications on OCIs. Speaking of SDKs, so OCI also provides several different software development kits that are available for easy integration with our APIs and our different resources, including SDKs for a few different languages like Java, Ruby, and Python. We also have our command line interface or CLI. This is going to provide you essentially with the same functionality as the console, plus you can do a little bit more, run more additional commands, but everything is working through a command and it's running on the Python SDK. So that's how it's working underneath. And then we have our infrastructure as code. So we have Terraform. Terraform is a very popular infrastructure as code software that allows you to define your infrastructure resources in files up front that can persist, version, and share. And for Terraform, Oracle has built a wrapper tool for it called Resource Manager. This is a free tool to use within OCI, and it's going to help you install, configure, and manage resources using that infrastructure as code model. If you're already, running Terraform and have your Terraform scripts, this is a very easy way to implement it in OCI through Resource Manager. And then last but not least, we have Ansible. This is another infrastructure as code tool, mainly used for configuration management and orchestration, but it can help with the provisioning of cloud infrastructure, deploying and updating your software assets, as well as orchestrating your more complex operational processes. So we'll go a little bit further into each kind of tool that we talked about. The first one I'll touch on is the command line interface or CLI. So this is a tool that can be used on its own or with the console to complete different tasks in OCI. Like I mentioned, you can do some additional things like running different types of scripts, having additional commands in the command line further out than just, the normal console. And how it is working is the command line is built on the Python software development kit. It can run on Mac, Linux, and Windows environments. The Python code makes calls to the OCI APIs to provide you functionality implemented for your various services. So the command line is really useful for your managerial tasks. You can do things like find and locate resources, maybe audit your tenancy by using query commands. You can also build and script different things to perform specific functions like managing your compute instances. Maybe you want to programmatically turn on and off environments to save on costs. So you can execute scripts using the command line to also help, with building out your infrastructure. So that's one way of building out your resources using the command line. It's different than using, the graphical interface of the console, as well as it's very different than using a pre-baked software already, like a Terraform or a Pulumi. But the CLI is flexible and scalable in where and who uses it and can be accessed through the console through Cloud Shell, Developer Image, and PowerShell. So next we have our OCI REST APIs. So like I mentioned, these are going to be your typical REST APIs that use HTTPS requests and responses. This is essentially what is going to be called when using the Python SDK for the command line. You'll be calling them when you're using other SDKs to build out, different applications. And permissions for these API calls are applied by the user, and your command line access is all just going to be defined in your config file. So the CLI kind of allows for many of the tasks using REST APIs to be completed and just have an overall easier deployment. Next, we have software development kits. So an SDK or software development kit is a set of software tools and programs provided by hardware and software vendors that developers can use to build applications for specific platforms. And each SDK is going to provide you with the tools that you need to develop an application, like code samples, documentation to help you create, test, and troubleshoot. So you can build and deploy applications integrated with OCI services using these SDKs. In addition, if you want to contribute to the development of the SDKs, they are all open source and available on GitHub. And utilizing an SDK is just another way that you can script out the different tasks you may need to complete in OCI, such as building out your infrastructure. And scripting with the SDKs and command line, these are all just abstractions, right, of using these OCI REST APIs and can be another way of kind of automating the building out of your resources and provisioning of your resources. But again, it's not going to be as nice as a, targeted infrastructure as code tool. Okay, last but not least, before we start our infrastructure as code discussion, I do want to talk about Cloud Shell. So hopefully if you guys have been to the OCI console before, you're familiar with this. But in the console, you can access Cloud Shell, which is a free web browser-based terminal accessible from the console, and it's pre-installed with a bunch of, useful tools like kubectl, OpenTofu, etc. Each user is also provided with 5 gigabytes home directory, which is going to provide you with persistent storage to your files, and it's going to run under the same permissions as your console access. So if we have time, we can take a look at what the Cloud Shell looks like in your console today. All right. So I'm gonna now start our resource manager discussion before we go into the console. So what is resource manager? Resource manager we're defining as kind of Terraform as a service. So it's a fully managed service that lets you provision and manage your infrastructure resources using Terraform. So you can bring in your own Terraform files and template definitions and easily create and manage your infrastructure resources. So this allows you to use infrastructure as code to automate provisioning across all of your OCI resources like compute, networking, storage, and more. It has support for the command line, SDK, and console. And Resource Manager is going to help mitigate a lot of the problems that users can face when deploying resources on the cloud. So you can write your Terraform configuration using HashiCorp config language and then use it to create multiple environments. So if I need to create the same stack over different regions for like DR, anything like that, that's where Resource Manager will really shine. Something that's really great about Resource Manager as well is that it's going to save the state securely for you on object storage and will also lock it if multiple members from your team are trying to modify it, preventing any possible corruption or inconsistencies. And you can define permissions for your team through policies and give them granular access for various Terraform actions like plan, apply, and destroy. So it's integrated very well with IAM. And because Resource Manager is cloud native and built on open source standards, it integrates very well with our overall OCI platform, like tagging, key management service, and other OCI services. So how does it work? So there's multiple ways to get started in Resource Manager. First, you want to start with your authoring of your Terraform config files. So this is what's actually describing your end state infrastructure. So you can either write them yourself, you can start with some sample templates that we have, or you can just import existing infrastructure in a click. And I will show you that process in the demo. Once you've created your stack, that's when you can run a plan job. So when you run a plan job against a stack, it's going to parse your configuration and will create an execution plan for you, but it's not going to take any action on the stack. It'll just show you what it's going to do. And then once the plan job is completed, you can actually look at this execution plan by viewing the jobs log entries to confirm that it's going to perform all the expected operations and in the correct sequence. And then once you have that execution plan, now you can actually provision your stack with the resources that you define in the configuration. So that's what the apply job does. It takes that execution plan and will actually apply it to the stack, resulting in a fully provisioned stack of resources. So I mentioned how Resource Manager can save your state. For those of you who might be unfamiliar with Terraform, essential information about the state of your resource configuration is going to be maintained in a file called the state file, which is a JSON file. And this is for, every sort of Terraform stack that you're creating, whether or not you're using Resource Manager. And this state file is going to map your stack's resources to your configuration and will also maintain really important configuration details like resource dependencies. So when you're using Terraform just open source, if you have multiple people working on the stack, you always want to make sure that the state file is always being updated and maintained, and there's nobody corrupting it or changing it or accidentally deleting it. Because essentially, what the state file does is it's just mapping your configuration to your actual resources. So you always want to have that maintained in a secure location. That can be more challenging to do when you have, multiple users from your company all accessing the same stack and Terraform files with that particular state file. So what's nice about a managed service like Resource Manager is it's going to automatically save your state file, and it will generate it every time you run a destroy or an apply job, and it will also lock that as well. So I'll show you again where you can view that state file in Resource Manager. So yeah, that's one of the great things. It also supports state locking. So what we mean by state locking is only one job at a time can run on a given stack. So if I try running a apply job and somebody else wants to run a plan job, they actually have to wait until my apply job completes before they can run their job. Hopefully everybody can see my web browser. So right now I'm just in my home page of my OCI instance, and we will be taking a tour of Resource Manager today as part of the demo. So I'm gonna click my main menu button and then go into Developer Services. And then Resource Manager has its own little section here. So I'll go ahead and click that to take us there. All right, so if you're unfamiliar with Resource Manager, I recommend taking a tour. It's just going to get you familiar with the different options you have to get started. It also has some quick starts here, so you can get started with creating a stack through private template, connecting a source provider from a compartment. These are some sample templates. You can also get started to provision, different architectures within OCI. We have some tutorials linked here, and then also links to more documentation and kind of what's new with Resource Manager. But I'm going to take us to get started in the stacks section. I'm going to make sure that I'm in my proper compartment. So I'm going to be working in the Vision Corp infrastructure compartment. So to create a stack, there's multiple different ways you can do it. The first and foremost way is just uploading your own configuration files. So if I already have a lot of my .tf files, I can, choose from a folder on my local machine. I can drop those files in an object storage bucket and click from there. Or if I have a zip file, I can drop my zip file in there. The next option is using a template. So these are Oracle provided templates, or you can use a private template as well if you want to upload a private template and start from there. When you do select templates, then you can see the list of all the different ones that Oracle provides. It's separated out by type. So we have some quick starts using a particular or specific like deployment scenario. So you can see some of like the types of architectures, like using different services, or like a web application with auto scaling. Then we have service specific ones. These are going to be including particular services in OCI. So either with like a private endpoint, maybe we want to use APM from Observability and Management. We can use our Vision AI service. These are networking ones, data science, compute, and block volume. Then we have architecture specific ones. You can choose from some different landing zones to get started. These are different templates, again, for particular landing zones, or, just including a certain type of architecture, like a hub and spoke network topology, or even like a sample e-commerce application to get started. And then the private one would be if you had already created a private template within Resource Manager and you have the permissions to view it, you can access it here. So that's one way you can get started is through a template. The third way is through a source code control system. So if you're using a source provider like Oracle DevOps, GitHub, GitLab, or Bitbucket Cloud or Server, you can actually connect up to that and then pull your different files from the repos that you have set up there. So if I chose a GitHub, I would have to configure this source provider. So I could create one here, or I could create one out of this area too, in just the main page of Resource Manager. But essentially, to configure a source provider, you'd have to give a name, description, choose the compartment, and then designate either a public or private endpoint, and then the type. So again, these are the different types that we support right now. You'd have to put in your server URL and maybe your personal access token for something like GitHub. But depending on what it is, it'll ask you for different sorts of configuration information. And then once you have that and validated that, then you should be able to choose from here. You'll see a list drop down here where you can choose your source provider. Then it'll go in through your like access token, see your different repos, and then you'll be able to choose the repository and branch that you want to pull from. And then last but not least, we have existing compartment as well. So a lot of times we get a question of, maybe some companies or teams have already started working in OCI. So they've already been starting to create things, deploy things, maybe create a network, create web servers, whatever infrastructure it is. And they're all right now just doing it manually and they're just clicking through the console, but they want to start using infrastructure as code as a best practice. So a lot of the questions we get is, hey, is there a way to kind of take what we've already deployed in OCI and kind of turn that into a generated script for Terraform and go from there? And so the answer is yes, you can use this last option called existing compartment. Essentially, what it's going to do is it's going to perform a resource discovery on a certain compartment, look at all the different services you have deployed and that you've specified. And then when you create a stack, it's going to generate out all of your Terraform configuration files for you. So how it works is once you select existing compartment, you can choose the particular compartment that you're interested in. You'll select your region and then you'll either choose all Terraform provider services or you can select the specific services that you want it to capture for you. So those are the 4 different ways basically that you will be creating your stack. Once you have chosen one of these ways, the rest is pretty simple. You'll just be naming it, choosing a compartment once again, and then configuring any sort of variables if you need to. Right now, mine is still clicked on resource discovery, so there's no variable configuration I need. And then after it, you can review the information and then create the stack here. So once you've created a stack, you can go in here and this is what the stack looks like. So from here, you can see the different jobs that we've run. You can also view the different variables that have been created or are needed for the stack, and you can view the most recent state file. So for jobs, if you click into this particular job, you'll see the logs from this job. So you'll see important information of Terraform being initialized, and then you'll see it working through and creating this execution plan for you. And then because it's a plan job, nothing is actually going to be added, but it is going to show you what it expects to do. So it expects to add two things, change 0 and destroy 0. From each job, you can download the configuration. You can also download the plan. Let me go back to details. And from here, this is where you could also like download the most recent state file as well. You can also view state for your apply and destroy job. So like for here, this is the most recent state file for the apply job. This is where you'd run your different jobs. So if I wanted to run another plan, apply, or destroy, I could do it here and it would start another work request. I can also import a state file. So if I have a more recent state file that was run like outside of Resource Manager, I could import this, download the most recent one, or view a drift detection and run drift detection. So drift detection essentially is going to be looking at your resources and it'll let you know if anything was modified or deleted. So we have run a drift detection report and it looks like it was drifted. So it seems like for this particular resource, it was deleted. So all of these are just going to show like nothing under actual and expected properties. It'll just show deleted. If there's any sort of modification, so let's say the resource still existed, but just certain properties were modified, it would say modified and it will actually highlight under actual and expected which ones were modified. And then obviously it was if it was in sync, then this would also say in sync. So it looks like somebody deleted the resources, but they didn't do it through a destroy job. They just deleted the resources outside of the stack, which is not a best practice. So you don't want to do that. But we've been cleaning up our tendencies. So that could be why. But that's what drift detection does. You can run a new one and it'll start a new work request for you. But this is a good way to actually see again what properties are in sync and if there are any that were modified or changed. The last thing I'll show you before I pass it to Olivia is being able to edit the stack. So you can edit the stack information kind of like after you create one, where you can change the variables, things like that, or you can edit it in our code editor. So this is similar to our Cloud Shell, but rather than a terminal environment, this gives you more of like a IDE environment. Looks very similar to Visual Studio, but essentially you can go in through one of the plugins in OCI and actually edit the Terraform directly on the web browser rather than having to edit it separately and then like re-upload your files. So this is a really neat trick. It just does take a while to load. But again, if you want to quickly make some edits and then run a plan job or run an apply job, this is a great way to go.
The slides and just kind of building off of what Uma just covered with Terraform and Resource Manager. There's also Ansible. So Terraform is going to be a good infrastructure as code provisioning tool, but it doesn't come with that configuration management piece. So that's more of where Ansible comes into play here. And it's going to be more procedural in nature, whereas with Terraform, it's going to be more declarative. And you can kind of see right here the syntax is different. So with Ansible, it's going to be in YAML. And you can use it for a variety of different use cases. So one is around continuous delivery. So this is more stage and test. So your Ansible inventory can be split to separate your environment into different groups of machines. So you can test your plays with a staging machine. And if that test passes, then it can be instantly run against production if you want. And Ansible can work with networks, load balancers, monitoring systems, and other devices that might need touching during a rolling update. So for example, you can add or remove servers from your load balancing pool and disable monitoring alerts for each machine that is being updated. You can also use it for things like orchestration. So if you are managing clustered applications, multiple data centers, public, private, and hybrid clouds, and maybe applications with complex dependencies, you can orchestrate your complex tasks with Ansible, so it can help ensure all these tasks happen in the proper order, that the database is up before the backend server, or that the front end server is removed from the load balancer before it's upgraded. So once again, very procedural in nature. You can use it for a variety of different use cases. And of course, you can use OCI with Ansible. So we have an Ansible collection with some sample playbooks, so you can explore those. You can modify those as well. But you can do this in Cloud Shell. So Uma showed that earlier, and it's kind of nice because Cloud Shell has a lot already set up for you. You can run it in your own terminal if you want, but you must install the OCI Python SDK, which enables you to write code to manage and provide OCI resources. And there's a few other steps that you need to do, but you can do this in Cloud Shell, you can do in your terminal, and then you can also, once again, explore some of the playbooks in the OCI Ansible collection. And then now diving into the monitoring piece and some of the different tools to help you get more visibility into your environment. So this is a high-level overview of observability and management, or O&M. So today we're mainly going to be focusing on some of these platform services right here, such as monitoring, notifications, events, functions, all of that. And then you have some of these management services under O&M, like logging, logging analytics, application performance monitoring, all of that. So today you'll get an idea of some of these different services and kind of how they work together to give you more insight into your infrastructure and your environment. All right, so going into monitoring, so all of your different resources like your compute, your database, or maybe your application services and resources are all going to continuously emit metrics to the monitoring service. And then you can view these metrics in the OCI console, the OCI SDK, CLI, or API, or different monitoring tools. And then based off of these metrics, you can set up different alarms. So for example, let's say for your autonomous database, you want to know if CPU utilization exceeds a certain threshold. So you can set up that alarm based off that particular metric. And if it exceeds 80% utilization, you can be sent a notification. So you're aware of that CPU utilization has exceeded 80%. And so you can set up various alarms for your different resources, and those alarms will kind of depend, once again, on the resource, just so you're more aware of what's going on. So this ties in with the notification service. So as we just saw, this ties in with monitoring. It also ties in with some other services in OCI. So Oracle Events, it ties in with the service connector and also applications. And so how this works is you would first have a notification topic. So you just give it a name. And then once you have a topic, you can add different subscriptions to that topic. And there's different channels or protocols for that. So if you want to be notified via email, you can make that your channel. You can do functions, you can do PagerDuty, you can do Slack. And so you would want to also make sure that these are active subscriptions. So if the subscription has not been accepted, and then it'll say pending, and therefore you won't receive that notification. So you want to make sure that it's active and that you've accepted that subscription. But essentially, once you have your notification topic and then your active subscriptions, you can then tie it in to some of these other services to be aware of what, once again, is impacting your different resources and all of that. This is another service as well. It's the event service, and there's three core concepts. So first is the event that's impacting your different resource. So in today's use case and demo is when an object storage bucket is created, that's an event, or when it's deleted, updated, all of that. So there's different events that you can create for your different resources, and then the rule is what you define. So going back to the object storage bucket, if I want to know when one's been created, when one's been deleted or updated, I can kind of pick and choose from the list. And then from there, based off my defined rule, there's different actions that I can take. So I can invoke a function, send a notification, or I can write to stream. And you can do all three if you want. So just going back to notifications earlier, you just attach the notification to that event rule. And then whoever is subscribed to that notification will receive, yeah, that notification. And then going into functions, so this is more of Oracle's serverless offering. You can use it for a variety of different use cases, and it's going to be per use, so pay for execution, not for your idle time. And so one use case around functions is with budgets. So in OCI, you can set a budget on your tenancy, you can set it on a compartment, or you can set it on a tag. So let's say you set a budget of $1,000 for a particular compartment. You can then set up optional budget alert rules saying, hey, you've reached your budget. But in OCI, when you reach a budget, all Oracle's going to do in that case is just let you know it's not going to actually enforce that budget. So it's more of a soft budget. But you can leverage functions to actually enforce that budget and prevent any new resources from being provisioned. There's actually a pre-built function in the console. I think it's called the zero quota limiter, which would help you enforce that. And there's a few other pre-built functions for a variety of different use cases. So we can take a look at that briefly too in the console, but there are some ones that you can already leverage out there. And then going into logging and the different types of logs that you have available to get a little bit more traceability into your environment. So you have different types of logs. So first off, you have your audit logs. This is at more of a high level, more of clicks in the console, API calls to your resources. And so you can get a view of that. You can search your different compartments. And then you also have your service logs. So for a variety of different services or resources like VCN, load balancer, object storage, all of that, there's different types of logs that you can enable for those resources. So for instance, with your load balancer, you have two log groups. One is access logs and the other is error logs. So you can enable both of those for your load balancer. And error logs might be particularly useful to have enabled because if one of your backend servers is down, then that would end up in that error log group. And you can actually tie that in with a notification service to be notified of when that occurs. So we'll take a look at that today as well, but you can enable at the service level as well for some of your different resources. And then you also have your custom logs. So this is more for on-prem and multi-cloud resources or applications and all of that. This is just going a little bit more into your audit logs. So it records all API calls to OSA resources in your environment. So this is pretty key for any security and compliance reasons because it lets you monitor and keep track of activity in your environment. And with audit logs, you can see what activity occurred, who initiated it, time of the request, so stuff like that. And you can get activity from different sources like the console, SDK, and CLI calls since they all go through our APIs. So you have a little bit more traceability and visibility into your infrastructure. All right, and with that, I'm going to hop into the console to show you some of these different services. All right, so to get started, I first want to cover the notification service because once again it's pretty critical because it ties in with events, it ties in with the service connector, ties in with monitoring. So it ties in with a lot of different resources to keep or different services to keep you aware of what's going on with your different resources. So if you go to developer services right here, you'll see notifications. You can also just search right here for notifications and it should pop up. And then you can click there. So first step is creating your topic and also just making sure in general that you're working in the correct compartment. So I'm just going to go ahead and change this to this compartment right here because we already have one created. So yeah, first step is to create a topic. So really you just give it a name, description, and as with any resource that you're creating, specify in which compartment it will reside in. So that's the first step. And then we already have a topic created right here. So I'm going to click into this one. And then you can see right here the details, description, and then if you click subscriptions right here, you can see the list of subscriptions to this particular topic, and you can see that they're all active. So going back to earlier, if it says pending, that might just mean that the subscription has not been accepted. So therefore, they will not receive those notifications. So you want to ensure that it says active right here. And then you can check the protocol. So in this case, it's all email. And then from there, you can see what the endpoint is when it was created. And then if you want, you can delete one of these subscriptions. And then if you want to add a subscription, you would go right here, specify the protocol. It doesn't just have to be email. You can do a function, custom URL. And the nice thing about each of these different options is that it will give you some information right here for each different protocol. You can do PagerDuty, you can do Slack, or you can do SMS. So that's how you get started with notifications. You have your topic, you add all your subscriptions, ensure that they are all active. And then from there, you can start tying it in with some of the other services. So one service that we'll take a look at today is the event service. So under O&M right here, or observability and management, this is where you can find a lot of those different services. So you can go to event service right here, rules. And then from here, you can create a rule. So I'm gonna click this. You would give your rule a name and then a description for what your rule does. So in our use case, when an object storage bucket is created or when it's deleted, we want to be notified of that. So depending on the service that you select, there's different event types that you can define. So if you choose budgets, you'll see the list right here that you can pick and choose from. And then you can just type right here. So I'm just going to click object storage. So for object storage, this is a list that I can choose from. I can also get as granular as the object. So if I want to know when a bucket is created, when it's been deleted, when it's been updated, I can kind of just pick and choose right here. And then I can add another condition. So if I want to add another event type for maybe a different service, I can go ahead and do so. But if I want to get more granular based off a particular attribute, such as compartment ID, compartment name, namespace, resource ID, or resource name, I can filter that way. I can also filter based off a tag. So depending on how you're tagging your different resources, or you just want to be notified based off, resources in your dev environment or test or prod or something like that, you can go ahead and specify that right here. So there are ways of getting more granular with the event rules right here. And then based off this rule right here, you can select the action that you want to take, whether it has to do with streaming, notifications, functions. So in this case, we're just concerned with notifications. So you would simply just select the compartment that has your notification topic that you want to use. And then whoever is actively subscribed to this notification topic will receive a notification when this event above occurs. So if a bucket is created, if it's deleted, or if it's updated. And then, yeah, you can add another condition. So if you want to do a function or something, you can add that. And then, yeah, you can go ahead and create your rule. And then just building off of what Uma covered earlier with Resource Manager, you'll see the save as stack option with pretty much any resource in OCI. So it's pretty nice because you can save this as a stack and then use in Resource Manager or just have that stack handy. So you'll always see that option usually. And then you can click into your rule right here. So you can edit your rule if you want to change some of the conditions right here, like adding another action. You can disable this if you want. You can see any metrics down here, like events delivered, delivery failure, event matching. So if you want to add event or remove one, and then you'll see actions right here. So if you want to add one, you can. But that's just kind of an example of notifications tying into service. It ties in with other services as well. So it's pretty important to know about. And then another area that I would like to cover is logging. So once again, under O&M, you'll see logging right here. And so if I go into audit logs, so this is one of the types of logs. So this is more of clicks in the console or API calls to your different resources. So right now it's going to search through the logs in this compartment. So you can go ahead and change that if you want. So if you want it to be like infrastructure or a different compartment. And then from there, you can filter based off user and it might populate the list with any recent users or resource right here. So you can filter that way. You can also filter based off request action type, like get, post, put, patch, delete. You can also filter based off of event type, like getting instance, listing instance. So there's a list right here. And you can do custom filters, like maybe a keyword or something. You can also filter by time. So right now it's just looking at the past 5 minutes, but you can make that today, past hour. You can do custom. The only thing to note right here, so like if I try going more than 14 days, it'll give me this error right here. So that's kind of the um, boundary for that search. But yeah, you can do custom filter within 14 days. And then from there, you can see the event time, the user resource action and type right here. And then you can expand this to get more information, but these are your audit logs. Once again, kind of more just clicks in the console. And then if you go to logs right here, you'll see that this is where you can create service logs and also custom logs. So this is kind of more for custom applications or on-prem, all of that. So if you want to enable a service log, you would go right here, specify the compartment that you want to search for the resources in, and then this is a list of services that you can choose from. And then depending on the service, you might have different options for the types of logs that you can enable. So going back to earlier with your load balancer, so I'll select that. And then in this compartment, I don't know if we have an active load balancer, but essentially from there, you could choose the log category. So for load balancer, it would be an access or error log. And then you also have enable auto archiving to object storage if you want to retain your logs longer than the option right here. So if you go right here to log retention, you'll see the max that you can set to is 6 months. But if you want to retain that longer, you can select this option right here. And then we have some examples right here. So we have access logs enabled, and then we have error logs enabled. You can do this for your VCN. So let's just go into our load balancer error logs because this might be helpful if, once again, one of my backend servers is down or something like that. So you can get general information right here, like log type, the service, the resource, if you have legacy logs enabled, what this retention period is. So in this case, it's just a month. And then, yeah, you can see monitoring, explore logs, all this right here. And then you can click into that log group right here. So once again, more information, explore log group right here. And this is where you can see some of the different logs right here. So you can see the time that it occurred, the type. So this is, I think actually accidentally clicked into our VCN flow log group. So I'm going to click back to here, go to logs, go back to the logs right here. Go to explore logs. Right now, it has nothing to show because it might be showing recently. So I'm going to do last 2 weeks to see if we have anything. It also might not be here because I think once again we deleted our load balancer, but you can see the date time, the type, and the message for that log. And then let's say you want to be notified around different types of, oh, here it is. So if you want to be notified around different types of error logs, you can do so with a notification service and then something called the service connector. So you can see, yeah, once again, the list of logs right here, but if you want to be notified or focus on particular errors, you can go ahead and do so. So if you go to connectors right here and then click create connector, you can give your connector a name, description, and the compartment. And so there's different sources that you can choose from for your service connector. So in this case, we want to search through our logs. So we're going to select logging as our source. And then we want to be notified. So we're going to select notifications as our target. And then from here, you'd select the log group that you want to search through. So we want to search through our load balancer, our log group. So I'm going to choose this. And this is pretty important right here because if you don't define this log filter right here, you'll be notified of every single thing that ends up in the error log group. And there might be certain errors that you want to filter out or certain errors that you want to focus on. So this is where you can define those different properties. So you can see user agent, listener name, data error log type, and you can say equal to or not equal to a particular value. So this is pretty helpful for focusing on the errors that you want to be notified around. If there's something that's not as critical, you can define that property right here. But there's a long list of properties that you can filter out or focus on right here. Because otherwise, once again, you'll be notified of every single log that ends up in that error log group. And we saw that there's quite a few in that list. And then from here, this is why notifications is pretty important because you have to tie it back into a topic to be notified, and whoever is actively subscribed to this topic will receive those notifications. And then you can go ahead and create this connector right here. And you can see right here, you can even enable logs for your service connector. So just going back to your service logs. But yeah, that is notifications, how to get started with that, how to tie it in with other services like the event service and also the service connector to stay up to date with what's going on with your different resources. Yeah, so just to recap, you can use notifications and events to be aware of different events impacting your resources. You can also tie notifications into other services like the service connector, monitoring, all of that. You can use Resource Manager to help automate the process of provisioning and also managing the state of your infrastructure. And then there's a lot of services under O&M to give you more insight into your environment. And with that, I'll pass it over to Borna to take us through a few more slides.
Awesome session. Thank you, Livia and Uma. Really appreciate your time and help with this session. Hope it was a good learning experience for everyone. And also here on the slide, as you can see, we have a slide that helps outline the various learning resources, labs, and certifications that are available from Oracle University as well as our YouTube channel. And as you can see over here, if you enjoyed this session and like for us to conduct personalized training sessions for your organization, please do email us at our personal training email, and we will reach out to you. And also, if you want us to conduct just a hands-on lab, or if you want also our newly designed QuickShot Live Lab program for a more expedited hands-on learning experience, that's also available to you for specific cloud topics. Under the Developer Experience program, we co-develop solutions based on your own use case. Please remember that personal training is an investment we make in our customers to help them grow and develop their OCS skills at no extra cost to them. And here we have a calendar that helps to show our various offerings throughout the month. If you're interested in joining these other sessions, please pay a visit to our Day One and Beyond homepage and register. I believe the next slide shows our sessions for the following month as well. Yep, there we go. This also shows that our next session for the core series will be our Day One and Beyond Oracle Cloud Database Quick Start on October 7th. We hope to see you then. That being said, thank you for joining everyone and have a good day.